Hello, this is Captain Chaudhari. Today I want to speak about solar day, sidereal day and lunar day. And then I want to also speak about synodic and sidereal period of revolution of moon and planets. So first of all, let us understand what is this sidereal day, solar day and lunar day with the help of a simple diagram. Here is the sun. This is the orbit of Earth. Over here I have Earth, then moon, and let me also draw a distant star in line with moon and sun. Now here is an observer on the Earth. This is the meridian of the observer. At this time when sun, moon and star, all three are on meridian, start our time clock. The time for one complete revolution of 360 degrees in space takes 23 hours, 56 minutes and 4.1 seconds of solar time, which means that 23 hours, 56 minutes, 4.1 seconds of solar time is equal to 24 sidereal hours. That means one sidereal day. Now, we say that the distance traveled by the Earth is not so much as compared to the distance from the star. So these directions are assumed to be parallel. Now the person who had moon and sun and star on meridian at the time of start of count, he feels that, yes, of course, the star was on meridian, but sun is not yet on meridian. For that, the Earth will have to move a little bit, Earth will have to spin a little bit, and then only the sun will come on meridian. And when this happens from the start of count, it takes about 24 hours. Solar day means the time taken by two successive transits of sun of the same meridian. At the time of start of count, sun, moon and star all were online, but we have seen the star passing at sidereal day completion. We have seen the sun being on meridian at the end of solar day, but moon is not yet on meridian. Actually what happens is moon has its own orbit. It goes anti-clockwise as you see from top, or eastward as it revolves around the Earth. In its orbital path, the moon has advanced actually, and therefore for the moon to come on meridian, Earth will have to move a little bit more, Earth will have to spin a little bit more. By the time the Earth has come here, Earth has spun a little extra, this person will probably find moon on meridian, and this takes about 48 to 52 minutes more. And the time taken from the start of the count till the completion of this phenomenon is called a lunar day. Now, out of these three periods, the lunar day is most fluctuating. That is because of the close vicinity of moon to Earth. It should be noted that the 2356 4.1, which is the sidereal day duration, is virtually constant. These durations give you the rate of change of GHA by these heavenly bodies. Also, for example, rate of change of GHA by first point of Aries is 360 degrees divided by 2356 4.1. That gives you 15.041 degrees per hour. Same way, in case of sun, the rate is 360 divided by 24, that is 15 degrees per hour. And in case of moon, it is variable. So 360 degrees divided by 24 hours, then you can say 48 or 52, etc. So actually the rate is 14 degrees 19 minutes plus V in minutes. So now after understanding solar day, sidereal day and lunar day, I will try to explain you what is the synodic and sidereal period of revolution of moon. Now moon goes around Earth, and what we can see from the Earth is the changing phase from new moon to full moon and full moon to new moon. Now if we start the count from new moon and finish the count at new moon, that would be completion of a lunar day or lunation, or it is called lunar month. But that is what we can observe from Earth. But in reality, the revolution period of moon is different than this. Now if we talk about a lunar month, it is about 29.5 days as we see from the Earth, the interval between two successive conjunctions. But what is the actual period in which the moon goes around the Earth in space by an amount of 360 degrees, which is the sidereal period. Let us try and understand sidereal period and synodic period of Moon's revolution round the Earth. For that, let's draw the same diagram again. Here is the Sun, and this is the orbit of Earth. This is the Earth, and let us say, let there be a distant star. So what we see is Moon in conjunction, and at the same time Moon, Sun and the star in one line, and this is the start of count. We start our count now. At this moment, the phenomenon that we see is Moon, Sun and star in one line. At the moment, what we will focus on is Earth, Moon and star, distant star in one line. Now, as the Moon goes around the Earth, revolving around the Earth, let us say Moon has completed 180 degrees of revolution in space around the Earth. Now somewhere over here, Moon completes one revolution around the Earth of 360 degrees in space, or in other words we can say that Earth, Moon and distant star, which were in line at the start of count, once again the same star, Earth and Moon are in line. That means the Moon has actually completed a precise revolution of 360 degrees in space, as witnessed by the star, with the star as referee. This is the completion of a sidereal period of revolution. But at the start of count, the Moon was in conjunction, that is 0 degree elongation, and Moon is not yet in conjunction. For that, Earth will have to move a little more, Moon will have to revolve a little more, and over here we find that Moon is again in conjunction. So the period from here to here is conjunction to conjunction. So where sidereal period of revolution takes about 27.3 days, synodic period of revolution, which is conjunction to conjunction, takes about 29.5 days, a little extra over 2 days. This difference is the difference in sidereal period and synodic period. From Earth, what we can observe is the synodic period of revolution. Now there is a very simple formula. 1 upon synodic period plus 1 upon 365.25 will give you 1 upon sidereal period. So when we put 1 upon 29.5 plus 1 upon 365.25, that gives you approximately 1 upon 27.3 days. This is the relationship between synodic period and sidereal period of revolution. I hope you have understood the synodic and sidereal period of revolution of Moon and the relationship between them. Also, I hope you have enjoyed understanding solar day, sidereal day and lunar day. Let us now try and understand the synodic and sidereal period of revolution of planet round the Sun. To understand the synodic and sidereal period of revolution, let us look at the solar system once again from top, that is from the north. Let us say here is the Sun, and let me draw the orbit of Venus. To understand the sidereal period, we have to take the star as referee. So let us assume that there is a star very far off, right? And at this occasion, the Sun and star, they are in one line. While the Sun is in direction of the star, the count starts. From here, when we start the count for sidereal period, next when the Venus comes back to the same position, it would be assumed that Venus has completed 360 degrees of revolution in space around the Sun, and that is sidereal period of Venus. Or in a simple language, we say that the same star has come back in line with Sun. So this was sidereal period. To understand the synodic period, we don't have to look at the star, because in synodic period calculation, Sun is the referee. I will draw the orbit of Earth. Now, assume that the Earth is here, and as I said, don't look at the star, just look at the Venus and Sun. You will find Venus is an inferior conjunction. Conjunction means 0 degree elongation. 0 degree elongation means from Earth we see the Venus and Sun in line. We start our count now. Now, synodic period is from one conjunction to similar conjunction. So when the Venus is in inferior conjunction, we start our count, and when next Venus is again on the inferior conjunction, it is the completion of a synodic period. Now there is a formula which is 1 upon Sy, that is synodic period, equal to 1 upon sidereal period So in case of inferior planets, we can say 1 upon sidereal period of say Venus minus 1 upon 365.25. In case you want to find out the synodic period of superior planets, then we have to bring this 1 upon 365.25 here and sidereal period of that planet over there. And that is the only difference. But in any case, this formula holds good. The difference of the two will give you the reciprocal of synodic period. So now if we put the value, in case of Venus, the sidereal period is 228 days. When we put the values here, you find out the 1 upon synodic period of Venus gives you the synodic period to be 606 days. That means for 303 days, the Venus is on easterly elongation, and for another 303 days, Venus is on westerly elongation. Why I am saying elongation? Because elongation is referred to with respect to Sun, and also why I am saying 303 days Sun is on easterly elongation, 303 days Sun is on westerly elongation, because both elongation as well as synodic period are related to Sun. So when we start the count after the inferior conjunction, after 228 days, Venus is back here, but Earth is not able to complete one revolution. Earth will be somewhere here. Now when the Venus has completed 2 revolutions and Earth has completed 1 revolution, and thereafter Earth is on the 2nd revolution and the Venus is on the 3rd revolution, somewhere here it will so happen that Earth, Venus and Sun are once again in line, and this would be called the subsequent inferior conjunction. So when we had started our count after this inferior conjunction, next inferior conjunction has happened after more than 1.5 revolution by Earth and after more than 2.5 revolution of Venus. That is after about 606 days. I hope you have understood the meaning of sidereal period and synodic period, and also if we know sidereal period, how we can find out synodic period and vice versa.